will give a quick overview of what's going to happen within the next couple of weeks. So basically, it's going to happen every week. So initially, we were planning to have this every month, but due to the demand and at the same time the number of speakers and heroes we have to share on their knowledge on machine learning, basically we're planning to do it weekly. And in terms of the number of sessions we have planned already, we already have planned for the next 3 months. So if you can check this set of slides, for the next couple of weeks in August, we have, for next week, we have a panel discussion with Cyrus and Rustem and other ML heroes. So instead of a talk style or a meetup style set of presentations, we'll have a panel discussion where we'll ask them a couple of questions related to machine learning, data science, machine learning engineering, and we'll probably ask a couple of questions on how they became ML heroes and how they had a chance to use ML in their lives. The week after that, we'll have Or and me talking about some other aspects of machine learning and data science. So for Or, he'll talk about ML and AI as subsets of data science, but basically he wants to talk about what determines the intersection of those things. And I'll share a few stuff about using SageMaker with R, the language. So most of the examples you'll see online are in Python. So I'll also share some examples on how to use R. If I have the time, I'll probably share some techniques also on how to use R with, let's say, Apache MXNet and or the step functions and other things that you should probably be different when you use R instead of Python. The week after that, we have one-on-one interviews. So as you can see, it's alternating. So first we have a panel discussion on August 15, and then on August 29, we'll have a one-on-one interview with Or and Augustinus. So for Or, the one-on-one interview, we would be talking about ML and AI in real estate. And then with Augustinus, we'll be building a production scale AI and ML system. So the topic would be revolving around those things. September, we have we'll have a panel discussion. We'll have talks on step functions, like SageMaker, Batch, and Fargate for deep learning pipelines. We'll also have a talk on building a bot that plays videos for the toddler. And then we have a one-on-one interview with Julian. And then finally, with Matthew Fryer, we'll be creating and scaling AI in enterprises. So we have a lot more sessions in the pipeline. We have a couple of talks already planned for October and November. But if you have the opportunity to reserve your slot in Eventbrite, feel free to do so, because initially we tried to limit it to just 100 or 200 participants. But then I realized might as well open it to up to 500. So if you can also invite some of your colleagues and friends to join us in these free events, feel free to do so.
So, and okay, can you guys see the screen? Yeah, I also use other. It look like it's pieces. It's okay. Yeah, never mind. Just try. Yeah, let me continue to the presentation. This should be working. And okay, now let me start to discuss the project detail and the function and how to use machine learning service to create an online teaching platform. We call it all screens. And first of all, the most important feature for all screen is that teacher can see all of the student screen at the same time. Sorry, this is yeah. I see the screen look like freezes for the PowerPoint. Let me restart it. Sure. Sorry for a moment. Let me stop the sharing and let's try share again. Little bit technical issue. Sorry for the. Okay. Yeah. First of all, this is the screen for the all-screen demonstration. Yeah, can you see? Yeah, this is the teacher screen. Teacher can communicate with student and see all of the student, and then every second.
咁我 send 咗個 message 俾啲同學仔啊，咁我哋可以 individual 收到嘅。喂，但呢個點樣 send 個 dark 嘅 screen 俾我
？Yeah, and I can see all of the student screen and send message to each student and even call them and take the actual attendance from the screen capture. Who don't share the screen with and do nothing, they will count for the absent in the class. Okay, this is the demo, but here is the architecture for the all screen. Yeah, okay. And is that in the background we are using Amplify to create the serverless web applications, and the application is connect with AppSync so that we can have the interaction between the teacher and the client, the student, and it's interactive with the subvariant client. And subvariant client is using Poly to generate speech to text, and here's the general architecture. And then teacher can communicate with all of the students through AppSync. Yeah, here is I just see the screen. Yeah, here's the architecture. The screen is connected to all student and teacher with AppSync, Amplify, and then the submarine client will communicate with Amplify, and then use Poly and speaker to generate message to tell student message. And here is the virtual tutor.
Please click on the Start Screen Sharing button and share your screen to me.
Yeah, here is two student screen, two browser in two students. And then teacher can communicate with the teacher panel, and then all students will be able to receive the message and individual message. Okay. Yeah. Oh. And also, recently we also integrate with Amazon Connect. As the problem is that when doing online teaching, some of the students may not be online, or some of the students is stay online, they are not stay in their computer, and we can call them just with Amazon Connect and Amazon Lex. And here's the demo. Everyone will got a phone call together.
打電話啦 ，OK， 我哋而家準備打電話啦。
Yeah.
好 ，call， 打 call 全部人啊。
Every student will when we got a phone call together.
啊，準備響機㗎啦，應該。係啊，出緊 call 㗎啦。影住部手機先。響緊啊！喂，俾影下個手機，響罩。喂，跟住接電話。
Every
接電話，接
student
電
got
話。
a phone call at the same time.
嗱，第一批同學。
Yeah, and we can call individual student or just give the call to student who don't attend the online classes.
係響晒啦。
Here is the recently released a blog post about the system to make phone call and do the very simple survey with Amazon Connect and Lex, and we can just upload the Excel file to the SD bucket and then make a phone call and get a complete some simple question or survey, or just like the previous screen, we can integrate with other system, but with SQS, put a JSON message in there, and then everyone got a phone call. You can check out the blog post if you want to use our system. Everything is open source. And here is another demo to make the correction, but I don't take the demo. And also we want to have the proactively. If there's something we're doing assignment or test, we want to have the virtual tutor to monitor of student. This is called work alone mode.
You have to work on your text alone.
Actually, the system is doing a face recognition. Okay, doing the face recognition, and if students have a friend to working with them to the test together, the submarine host will
You have to work on your text.
submarine host will recognize that if someone is working with you, and warn the student and send a message to the teacher. The teacher will receive a Google Map. Someone is cheating at home, and then the screen will be saved into SV. And actually, we have also some tools to help students when they are studying at home. For example, here is a Kendra integration.
Let me check your question with Kendra. You can check CH01 Web Application Concept and, in summary, Web Application Concept. 1. A web application or web app is any software that runs in a web browser. It is created in a browser-supported programming language, such as the.
Actually, behind the scene, I am upload all of my lecture slide and course material into SV, and then use Kendra to build an index. And the student can ask questions about the subject through the Sumerian host, the virtual tutor, anytime they like, even though not in the class. And then Kendra will check with Kendra for the answer to answer student question about the subject. And here's the architecture. We have done it previously. It's very early. There is no lags and Kendra integration, so that we are doing the solutions that students ask questions from typing or talking. If they're talking, we will use transcript to translate their extract their sentence and question, and then send to the lags, and we'll check the. First of all, check with the it's multi-language support. You can use Chinese, Japanese, anything, as the input data will be first go through the Amazon Translate, become the English, and then we will also analyze the sentence with comprehend, and then for different sentiments, if the student feel unhappy, the Sumerian will have different answer and different motion to tell student different style. And for the question, whatever question, we will first send the question to the API gateway, and Lambda will query Kendra. Here is also, we have implement something funny for students. Student can talk to my virtual tutor for anything with any language that is Amazon Translate support. For example, it's funny.
Your virtual tutor. Nice to meet you.
Don't let me keep you up. Get some rest and we can continue this later.
Yeah,
You look like you're ready to take on the world.
Virtual tutor for anything. Even though you tell her, I love you.
Temporary statement.
In English,
I like you too.
in Japanese,
That's great to hear.
in French,
I like you too.
yeah. Here's the architecture. Actually, we will build something like small talk from Google with Amazon Lex, and you can talk to her with anything you like. Good morning, hi, anything you like. He will have some answer for the teacher, from the teacher to the student. You can use Smile and type in, actually transcript, comprehend, translate. For the campaign result, we will guide the submarine host virtual teacher to do different gesture and talking style, and reportedly it will speaking out the answer. And we just demoed the work alone mode previously. Yeah, for the work alone mode is that there is a lot of complaint from the school about that you don't try to send the student face or home or something image into internet as a lot of funny story there. Yeah, there's something talking something and not good, get matter something. Yeah, there's a reason why for the locally we want the TensorFlow JS in the browser to do the face recognition and then make the function for the work alone mode. For student webcam, we will try to not send the image to the cloud directly for the privacy issue. And actually, for the all screen, it is a school edition. For school edition, it's much more powerful. It's the last line for my tongue, but this is an interesting demo. Yeah.
Hello, Linda.
This is my student.
Good evening. Welcome to IVE Cloud Innovation Lab. Hi, Sinching, nice to see you. I'm Linda.
This is the student
your
computer
assistant
screen.
Today. First of all, thank you for working on your programming exercise.
This is a
I'm very
programming class.
excited to be here and answer your questions. You can hold down the mic button and say, "Show my lab mark."
Student can
Show my lab mark.
query his mark for the
What is the
programming
lab
exercise.
number?
1.
You have completed 0
He
tasks.
hasn't started working on anything, so 0 mark. And this is face recognition to the eyes focus from the virtual tutor will look at the student face. Student is writing Python code now.
You forget to set up your
Here's
Python
the instruction
interpreter.
from teacher. The virtual tutor note that student forget to set up the Python interpreter, so ask the student to set it up. Yeah, the student start writing the first programming exercise that's a hello wow.
Good job. You have finished lab
When
01
student save the file
CHO1 hello
in
world.py.
his computer,
Keep
it will
going.
send to the cloud to run unit test.
Show my lab mark.
What is the lab number?
1.
You have completed 1 tasks.
Yeah.
You don't try to
If-
run iExplore.exe again.
This demo
I
is
will
that
kill it
students open the
immediately.
browser during their test. As you have the school edition, you can close the program. Don't let them to run IE.
Chow Yun Fat.
Virtual tutor will
Should be
monitor
not able to
student
help you
computer
writing
screen, and then
Python
if
code.
student doing something irrelevant to the class, if you want student don't doing something, oh, this student is, oh, they are looking at pretty girl.
Stop watching dirty thing during lab.
This case, the teacher will receive the message from the teacher and record down this student is doing something should not be in school. Yeah, this the classical version that's winning the AI hackathon. It's a much more powerful than the home version, as we have a Python application agent running inside the computer of the student, and then it can remote control the student to code program, record down, not just the screen. Well, for example, the keyboard typing, mouse movement, the file system changes, all of the information will be sent to a Kinesis stream, and then we will do the stream analysis to record everything to analyze student performance. This is the much more powerful version from the AI hackathon. But for the home version, we don't want to install the agent in a student's home computer as somehow very privacy. But for school, we will have the agent there. Yeah, this is compared between the home edition and the school edition. Okay. The final result is that actually my student attendance rate is dropped as the student can't just click the online button and then they complete the courses. They have to do things. If they do nothing, they will got 0 mark. And students have to study seriously. If they just click the online in the class and then go away, we will not get any marks. And students love the virtual tutor. It's just let them much more fun at time and can ask question to the subject host anytime. And also, student unable to just copy the homework from other and treating in exam. We have a lot of users. Okay, yeah, it's a thank you. I think this is part of my presentation. It's half hour. Hope you guys enjoy my presentation, and maybe the Zoom meeting is just a little bit quality is not good. But you can check out my blog posts and some technical blog, or we can share the slide and the link to your guys later. Okay, thank you. Is the real response stored? Yeah. We store everything in DynamoDB. Yeah, we keep everything. We even keep for the school edition. We even keep the keyboard typing, what they are typing, the mouse movement, so that we can make sure that students, if they are working in classroom, they just can't copy from the answer. For program exercise, it's quite simple. Just copy and paste and then submit it. They can get a mark. They learn nothing. But with the all-screen school edition, we will capture the keyboard mouse movement so that students don't do anything at school. We will calculate how much work they are typing, how is their mouse movement. If they don't type anything, they will got 0 mark. Okay, any other question? Yeah. If I next maybe less Alex can continue his session if there's no question for my part.
Cyrus, can you hear me?
Okay, yes, I can hear.
Yeah, so just a second. So I have a question. What's the maximum number of students can you have for a session?
Yeah, we have tried it with 2 class of students together, say 60 to actually we can support a lot of students. If you review the architecture is just a 100% serverless, and from the client, the submarine host is run locally in their browser. So there's this minimum communication loading between the teacher or the system, everyone with some Lambda function to handle it. So we can support a lot of students together.
Okay, thank you for that. And does it support mobile device?
Yeah. We tested we can run the system in Android, but for iOS, we have the problem is that the submarine may be too powerful, and it's already crashed down. But for the real usage, we just want to capture student activity in the class with their computer, but not mobile. So even though it can run with mobile, but this is not the design for our applications.
Okay. There are actually a couple more questions coming in.
Yeah.
So have you answered the first one? Is all the VR responses stored in Dynamo? Hello, you there?
Any other questions?
Yeah, Cyrus, are you there?
Keyboard. filter them. Yeah. Actually, we capture everything. We don't do any filter. As to be honest, some guy may think that the privacy for the student is not good. Yeah, you capture everything. It's the screen, the keyboard, mouse. We want our students working in school. Doing lab, they know that if you go into the lab and then you should do your lab exercise, but not playing computer game, watching YouTube. Yeah, there's a reason why we have our students to know that once you get into the lab exercise and get into the lab, you have to do your homework, do your lab work. If you want to do other things, you can go out. We don't care. Okay, if you get in, we will capture everything from your computer. Oh, sorry. Yeah, the voice quality is not good. Yeah, your guy. It's okay. Is it better now? Okay, and any other Q&A? I see some of the order. Hello?
Yeah, actually, Cyrus.
Yeah. Let me answer the question again.
Yeah. Yeah, worst case, Cyrus, in case that they couldn't hear your answers, we can probably just send them a direct message or answer them in the chat. Yeah, so it's good. It's actually good that we were able to hear your talk in a very clearly. Yeah, so at least if it's choppy now, that at least we were able to hear your talk properly. Yeah, Cyrus, can you answer one more question before we proceed to the next talk? Cyrus?
Hello? Can you hear me?
Yeah.
But one more question. Let me answer maybe one other question. Can I said install is a student? Yeah, everyone can install this project. Yeah, we open sources in GitHub and we have installation YouTube set up. But you need to follow my YouTube to set up, as it is a little bit complicated since there is summarian and not amplify, and you need to have some of the manual steps to handle it. And okay, you think that AI engine with government. Maybe I stop here first. I try to answer the question later or in the test manner.
Sure. Yeah. So thank you again, Cyrus.
Okay, that's Alex.
Yeah, thank you so much. Really great talk and demo. So yeah, so for everyone, give him a very big round of applause. All right. So we'll start the next talk in 3 minutes. There you go. Please give Alex a big round of applause. Go for it, Alex.
All right, hey, how's it going? Let me go ahead and share my screen here. All right, Joshua, can you confirm that you can see my screen, the PowerPoint over here?
Yes, confirm.
Great, thanks. Hey, so thanks, Josh, for the introduction. Like you said, I'm Alex Schultz. I'm a machine learning AWS hero, and I'm going to be talking about bringing your own container to Amazon SageMaker. So a couple quick notes about myself. I'm a software engineer. I've been developing for a little bit over 10 years now. As I said, I'm an ML hero as of last year. And I just published my first course on Pluralsight as well. So also getting more into like teaching and things like that. So in this talk, what we're going to do is we're going to start off and we're just going to kind of briefly talk about the different options that you have with SageMaker specifically related to training. And so there's really three approaches here. There's the built-in approach. We can use pre-built images. And then kind of the meat of our talk is going to be this custom do-it-yourself approach, which is what is going to consume the majority of this talk. Then we're going to actually dive deeper into that and kind of go through the steps of how you can bring your own SageMaker container/algorithm and actually use that for training at scale in the cloud. And so the pieces there that we're going to talk about are just the general overview of the whole process. There's some structured requirements that you need to kind of follow in order to utilize SageMaker. And then we're going to talk about how we can use our GPU with training and containers and stuff like that. And for this example, it's not going to be necessarily about a specific algorithm, but we're going to be using a framework called DARKNET, and the model architecture that we're going to be using is YOLO version 4. And I'll kind of explain a little bit about that in just a bit. And then at the end, I've cheated a little bit. I've taken advantage of the fact that this is a virtual session, and so I've actually pre-recorded my demo. So that should hopefully make the demo go smoother and reduce the amount of mistakes, and you know, make sure that I can kind of get everything covered in the short time frame, because there's actually a lot of content to go over for doing this. So, all right. So first off is the various options in SageMaker. So I kind of briefly talked about how you can utilize the built-in algorithms, and this is the simplest approach. This is the least amount of work for you. It utilizes these ready-to-go algorithms that AWS has gone and optimized for machine learning training. Many times the performance of these models that are built in outperform the ones that are found in the actual archive papers or the GitHub repos and on stuff online. So we're talking about bringing your own container, which is considerably more work than using the built-in one. So what I would encourage you to do is, before you just decide to roll your own container and algorithm, check back periodically to see which algorithms are provided out of the box, so that maybe, you know, even if you've done this work yourself and you've provided your own algorithm, chances are the data scientists at AWS have done something to optimize that particular algorithm or model that you're trying to use. And so it's worth it to kind of check back periodically, because they continue to add more algorithms over time. And finally, the last point with this, in fact, all of the SageMaker algorithms that we're going to be using, they're all based on Docker images. So it's good to have a good foundation using Docker and containers. So Docker really kind of makes this whole process feasible, and it's really powerful, as we'll see here throughout the demo. But just be aware that everything is based on Docker. So obviously, if the title didn't give it away, now you know. Now, if you wanted to find out more information on the built-in algorithms, you can go to this link down here at the bottom. And I think, Joshua, you said that the recording is going to be available afterwards. So I'm not going to dwell too much on these slides with the URLs and stuff. So this is what the built-in algorithms page looks like in the documentation. And so if you look on the left-hand side, here are all the built-in algorithms. Obviously, there's more here than what are showing up on the screen. So there's algorithms for just about every use case that you could want. Okay, so let's say there's not an algorithm for the particular use case that you're looking for. Another option is to actually use one of the pre-built container images that AWS provides. And what you can do is you can actually use your own code or model and an already optimized machine learning compute container image. And so what AWS has done is they've created these kind of baseline containers that already have like TensorFlow and MXNet and PyTorch and Chainer already built in. And so they've already done a lot of that heavy lifting for you, so that you don't need to go through and set all that stuff up. Because I don't know if you guys have ever done this, but this process is usually pretty tedious. And you know, I'm not sure, you know, they have a lot more experience optimizing this stuff than I do. So I would say that, you know, these are safe containers to utilize. And then also they have Docker images for training and inference. So a lot of times you're training, you're typically using more compute. You're using heavy GPUs and expensive instances and stuff like that. But you don't always need that same compute power for doing inference. And so they actually have separate images that you can utilize to do training or inference. And so that's just something to be aware of. And then of course the link to the different pre-built containers is found here at the bottom. All right, so now we get to what if, you can't use the built-in containers, you can't use the pre-built images with the frameworks that already have like TensorFlow installed. What if you have a framework that's obscure and AWS doesn't have a solution for you? Well, that's where SageMaker still provides the ability for you to bring your own container and image. And I call that the do-it-yourself approach. So with this, what we need to do is there's actually a set of predefined steps that we need to go through in order for Amazon SageMaker to be able to utilize this container. Once we have our container built, we then have to get our container pushed to Elastic Container Registry, which is the container repo within AWS. We can also, as I mentioned in the previous slide, we can utilize containers that are able to handle GPUs with training. And so one of the resources that is recommended to use here is these NVIDIA-based CUDA images, which we'll look at here in a bit in the demo. And then finally, once you have your image produced, then you can create an algorithm in SageMaker, which can then be used to actually kick off a training run, similar to how you would do it with the built-in algorithms. All right, so first off, it's kind of the required image structure. So I'll share a link here that kind of goes through the requirements kind of in more depth, but just at a high level, SageMaker is going to override the CMD command. So if you're familiar with Docker, you'll know that the command or the CMD command is what gets run whenever the container starts. And when that command that is essentially set to the CMD command, when that terminates, then the container terminates. And so what SageMaker does is it will automatically override either the train or the serve command based on whether or not you're using this image for training or inference. And so what that means is you have to implement a script or a program or something that can execute by using train. And so we'll see that here again, just in the demo. The next thing you need to be aware of is that SageMaker is looking for a specific directory structure. And that's because, again, being familiar with Docker, you have the ability to mount volumes within the container itself. And so SageMaker is going to automatically try to mount, or I'm not exactly sure the implementation details, but they do essentially take advantage of like mounting capabilities or somehow host volume sharing capabilities. And so they're expecting this directory structure to exist. So it starts at the root/op/ml. And then there needs to be an input directory in there with a config directory inside of that. And that's where you're going to put like your hyperparameter configuration data. And then for the actual training data, that's going to live inside of input/data. And then the subdirectories of that are going to be your training sets, your test sets, your validation sets. And so it all corresponds with the algorithm that you're using. And so again, this is the link to kind of walk through the specific image structure that's required for training. Now, when I go through the demo, I'm actually going to show how you can use the same container image locally to do training on your host machine and test things out using Docker volumes. And we're going to mount our data into these specific directories from the host machine. So yeah. All right, so once we've got our image built, then we want to go ahead and push it to ECR. And so if you look at the right-hand corner of this screen, there's the view push commands. This basically just will give you the exact commands you need to run in the terminal to log into ECR, tag the image or build the image, then tag the image so that it gets tagged properly for SageMaker and for ECS. And then the push command, which will actually upload the image here. So you can see that I've got an image that I've pushed to ECR already for the particular algorithm that we're going to be looking at. All right, so I talked about using the GPU and kind of the base container images that we can utilize. So NVIDIA has these base container images based on CUDA. And the nice thing is they've got all of the CUDA libraries and stuff already baked in and optimized. And so if you look at the tags section in this page, you'll see that there's a whole bunch of different configurations. So different CUDA versions, different versions of Ubuntu, different versions of CUDNN. So all of these are the prerequisites to actually doing training on a machine. And so if you use Docker and you use this as your from at the top of the Docker file, then you can start from this kind of pre-configured container image. And so you don't have to worry about installing all these dependencies, which can be a really, really tedious task. So if you're going to use GPUs, this is the way to go. And then I mentioned Docker also has the ability to train with the GPU. And so that's using this NVIDIA container toolkit. And so we'll see during the demo how you can train on your local host using this particular toolkit in the command line, and how we can specify the GPUs that we want our containers to have access to, so that you can actually do real-time GPU training locally, even through a container. Okay, so finally, once we have our image created, we have it pushed to ECR. Now we need to create an algorithm. So I'm going to kind of breeze over this. We're going to walk through it in the demo, but you have to create the algorithm so we can actually use it, which makes sense. All right, so like I said, we're not really going to focus too much on DARKNET per se in here, but I just want to give you a brief overview of kind of what this framework is. So it's not one of the built-in algorithms, which makes it a great candidate for kind of bringing it to SageMaker on your own. This was created by a guy named Joseph Redman. He's a professor, I believe, in Seattle, University of Seattle. He's kind of stepped away from the project though, and the project is now currently maintained by this guy, Alexei, and I'm going to butcher the name, but Butchkovsky. So somebody can correct me in the comments if they want. But here's the GitHub repo. And what's great is this guy's been really active in maintaining it. And they recently, within the last couple of months, just released the latest version, which is version 4. And for YOLO version 4, this is actually like state-of-the-art object detection. And I know state-of-the-art is a moving target when it comes to deep learning. But right now, this is one of the best algorithms out there to do computer vision object detection. So, okay, so that kind of wraps up the talk portion. And what I'm going to do now is I'm going to go ahead and try to switch to a video here. And let's see. Josh, can you help me out? Are you able to see my video here? Anybody? All right, guys, hang on a second. Sorry. All right. All right, so hopefully you can all see this video. So I'm just going to go ahead and start it. And then if you can't hear the sound, please let me know in the chat and I'll fix it. So here goes. All right, so to start off, we're going to actually look at our code here. And within this repository, the first file we're going to start with is the Docker file. And so if we look at the Docker file, you'll notice that we're actually using the NVIDIA CUDA 10.2 CUDNN 7 developer Ubuntu 18.04 image. And we have this aliased as our build image. And that's because we're going to use this image, which for reference, the developer image is actually quite a bit larger than the one that we're going to be using at runtime. This has some additional libraries and things like that added in so that we can actually build our binaries for our framework that we're going to be using. Now, when I actually create Docker images, what I like to do is I like to actually start up a container, usually from the Docker file that I'm building. And then what I'll do is as I start to kind of flesh out the details of my Docker file, I'll just run those commands directly inside of the terminal running that container. And then what that allows me to do is it allows me to very quickly test the build process for this container. So that way I can, once I actually run a command, then I can just simply add it to the Docker file and then rebuild that Docker image and then rerun it and then just kind of iteratively go through and build this thing out line by line. That way I know that when I go to actually use this image, I've kind of gone through and tested this thing as I've been building it. The other benefit of doing it this way is once you've built a previous line within your Docker file, that image layer has already been built, and so it doesn't have to rebuild. The next time you go to run that image, it'll simply use that kind of cached built layer within the image, and then it'll start up from where you left off. So this is just kind of a quick trick that I use to build my Docker images, and I'm sure I'm not the only one that does it this way. So if we move down into the second part of this Docker file, you'll notice that we now have a image that we're going to be using for the actual runtime. And within this part of the Docker file, we're referencing the build image, and we're actually copying the DARKNET, the binaries that we built in the previous image. We're copying those directly into this image so that we can go ahead and use the framework, but we don't need all of the additional libraries and stuff that come with that developer build of the image. Also, just to point out, we're establishing all of our SageMaker required directories here inside of our root opt.ml path. And so you see we have the opt.ml input config, and then we have our data directory. We have a model and an output and a checkpoints directory. And our code, that's where our code's going to go. So we're just basically, we've got a couple script files here. We have our train file, we have our serve file. These are the files that SageMaker is looking for when the container starts. In the case of serve, we're just going to go ahead and print an error saying that this image isn't for serving, we're not using this for inference. But train is going to call this setup, and the setup script is actually going to go through, and this is kind of where we bootstrapped our process for this framework. And within setup, what we're going to do is we're going to parse all of the hyperparameters that we've passed in through SageMaker. And those files are going to be essentially given to this image through a hyperparameters.json file. And so the other thing that this setup is going to do is it's going to go through and because those hyperparameters that we're using, we want them to actually affect the training process. The way that DARKNET works is it uses these config files, which actually establish kind of the model architecture and layer parameters and things like that. So we're going to parse this hyperparameters file, and then we're going to go through and actually adjust values within the config file, and that's what's going to drive the ability to change these hyperparameters through the SageMaker training console. Now, like I said, I've got the test data that I'm using here locally. And you can see this is from a data set that I used for a DeepLens project a while back. And I'm just using this as an example of how we can use this framework. But now that we kind of have everything set up in place, what we can do now is we can go ahead and run through the commands to get this container uploaded to ECR. And so if we look at the commands that are kind of given to us on the ECR page for that particular image or for that particular repo, then it gives us the login command and the build command, and then our tag command is next. And once we've tagged it, we can go ahead and push it to ECR. And like I said, I've already done this step, so the image is already there. Otherwise, you'd have to wait for all the data to get uploaded. Now that it's in AWS, we can go ahead and test it locally. And so I'm going to use this Docker run command and take advantage of the fact that on Linux, you can actually utilize the GPUs of the host machine within the container. So I'm going to use this GPUs all command, and that's going to make the GPUs on my machine available for training. Now, if I come in and just run this train command, and remember, this is the bash script that SageMaker is going to be calling, which calls our setup, which kind of bootstraps everything, and then we call the actual train command from DARKNET. And then you'll get the output log to the terminal. Now this log output is actually going to be pumped to CloudWatch, as we'll see here in just a minute. And so when we set up our algorithm, we'll actually be able to parse these logs and pick out specific values that we want to use. And in SageMaker, we'll be able to treat those values as metrics and actually graph them, which is pretty nice. So I'm going to go ahead and stop the training. All right, so now that we've verified that our image is working properly, we can go ahead and jump over to the SageMaker console and wrap this up. All right, so now if we come into the ECR console in AWS, we can see that our image has been actually uploaded to the cloud. Now, I actually uploaded this quite a while ago, but just for demonstration purposes, we can go ahead and click on our image and verify that it has in fact been uploaded. We can verify the size, which this is a fairly sizable image. Remember, we're using that CUDA NVIDIA Docker container, but this is actually smaller than if we had used the developer version or tagged version of that image. So size, when you're dealing with this stuff, it's going to be, you're going to have big images, but just be aware that, you know, the technique that we use to use the larger image to build our binaries and then the smaller image for the runtime, that will cut down on some of the size here, as you know, as we can see. All right, so we've got our image. The next step that we need for our training, and we can do this in any order, but we'll go ahead and verify I've actually pushed up the training data as well. So this data is in S3, and I'm not going to get too down into the weeds with SageMaker training because this is more specifically how do you get your own container into SageMaker. But just to verify, I've got my training data, I've got my testing data. It's the same data that I was looking at on my Linux machine, and it's, you know, it's all up here in S3. I've got two specific directories that I'm looking at. So there's a testing and a training. This is actually from a previous training run, so I've already got some additional directories here. This is the output from the training, which we'll see that where that was generated here once we get into the SageMaker console. All right, so now if we come over to the SageMaker console and click on the Algorithms tab, this is where we're actually going to create our algorithm that's going to use the container image that we just uploaded to ECR. Now to do that, you'd come over here and click this Create Algorithm, but I'm going to go ahead and just use this one because it's already got everything pre-filled. So that'll save some time of just kind of mindless typing and prevent some mistakes from, you know, while I'm demonstrating here. So I'm just going to go ahead and clone this. And this will just kind of pre-fill all of the fields in here, but you could just go to the create your own and walk through the steps. It's pretty simple. So we're just going to leave the name because we're not going to save this. This is where the training specification, this is where you actually put in the ECR Docker tag for your image. So we tagged our image with this particular tag, and this is where we're going to reference it. So if you had different versions of this image, you wouldn't just use the latest tag, you would use the specifically tagged instance of that image that was pushed to ECR. In our case, we're not using distributed training, so we're just going to leave this as no. And then we want to tell SageMaker what instance types our algorithm requires, or I guess I should say what instance types our algorithm is able to utilize. So because we're training an object detection model, we want to take advantage of GPUs. If we didn't need GPUs, then we could use some of the other, you know, non-GPU instance types. But because we need GPUs, I'm going to go ahead and use this MLP2 extra large. If we could, you know, let's say we had the ability to have multiple instance types, then we could just click on those and add those to the list of supported instance types. I'm just going to keep the one because I'm not, you know, I'm paying for this out of pocket, so I don't want my AWS bill to skyrocket. Next, we have our channel specification. So this is just our different training and validation test sets. So remember, these are going to come from S3, and these are going to get mounted into those data directories that we created in our Docker image. And so the images, or the paths that we need to establish are, for our algorithm, is training and testing. And so I've already got this, you know, pre-filled here. The supported content types in my case, I can accept either JPEGs or PNG files. So I've got those both selected. I want it to be file mode, and then no compression. And for the testing, when you come in to create an algorithm from scratch, it's just going to create the training one, and then you can come down and you can click Add Channel, and then fill out the information for the second channel. So this is already here because we cloned the previous algorithm. But if, like I said, if you were starting from scratch, you would have to do this on your own. So this is the testing channel, and again, this is just going to map to the testing directory here in S3. Go to next. Okay, so on this page, this is where we're going to configure our hyperparameters that are available to our algorithm during our training process. And so once we actually kick off a training run using this algorithm, these are the hyperparameters that are then going to drive the creation of that hyperparameters.json file that we saw in our setup script, that the setup script is going to be parsing. And so what we're doing here is we're just defining what the available hyperparameters are, and then what types of parameters they are. So in this case, DARKNET has a small version of their object detection algorithm, YOLO, and it's called YOLO Tiny. And so I have a hyperparameter in here that's just called use tiny, and basically there's two options, it's true and false. So in this case, this is a categorical hyperparameter, but there's also, you can also add hyperparameters with a integer parameter range. And so let's say you wanted something, like in this case, you want to specify the number of batches or epochs that the training is going to run, then you would need to create a hyperparameter type with the type of integer, and then you would have to give it a range, so a min and a max value. And with all these hyperparameters, there's also these optional is tunable, is required, and then a default value. So the is tunable, that's used for, I believe, hyperparameter optimization, which we're not going to get into in here, but is required, self-explanatory, and then default value, obviously, if you don't specify anything, what is the default? So I've got a few hyperparameters here, and then finally, the last section in the training is the metrics definition. So we talked about how the console output is going to be pushed to CloudWatch, and so what this metrics definition is doing, and again, this is optional as it says, but what this is doing is it's actually parsing those logs that are coming out of the console, and it's looking for essentially regular expressions. And so you can enter these regular expressions and create additional metrics that you're looking for, and then it's going to graph these. So in this case, really the kind of the key one that I'm looking for is the average loss. And so I want to be able to track the loss over the lifetime of this training run. There's also a couple more metrics that I've defined in here, just basically pulling whatever data I can out of the logs so that I can kind of see it visually instead of having to go into CloudWatch and try to, parse through all that manually. If we go to next, so this is where you can specify the inference specifications. So let's say if we wanted to actually host this model to do detection, then we could either create code within that serve script that we kind of ignored at the beginning, or we could define an entirely different image, a much lighter image. Maybe we don't need GPU support. Maybe we can kind of have a scaled down image for doing inference. In this case, I'm not messing with inference, so we don't really care. But this is where you would specify that information, and then you would also specify, similar to the training, the supported resources that you can use for doing inference with your model. So we're going to skip that. The validation specifications. So this allows you to actually publish your algorithm to the AWS marketplace, and then create a job to basically validate. We're just going to skip this. If we went to create algorithm, this would basically just create a clone of the one that I've already got. So I'm just going to go ahead and click cancel. And then if you click on it, you can see how everything's just filled in. And notice how we have our channels that we specified here in kind of a nice table format. If we go to the tuning specifications, we can see that JSON for the hyperparameters is now nicely formatted in a table. Also, the metrics are nicely formatted in the table. So we can kind of quickly see how this how this algorithm is able to be used. And we don't have anything for inference, so obviously that one is blank. All right, so we finally gotten to the point where we've built our image, we've pushed it to ECR, we've built the algorithm, or we've created the algorithm in SageMaker. Now we need to go and actually utilize our algorithm with a training job. And so this is actually, if you've done training through SageMaker before, it's pretty much the same process, except now, instead of using a built-in algorithm, we're just going to go ahead and use the one that we just created. And so once again, I'm not going to create a training run because I've already done that, and I'm basically just going to kind of walk through the steps. But what we can do is we can click on another one, go to clone, and this will pull the data from the previous training run. We'll give it a job name. I'm going to leave the role here because it already works. For the algorithm source, this is where you would specify your specific algorithm. So by default, this built-in SageMaker algorithm is going to be selected. So you want to go ahead and check this use your own algorithm, and then expand this down here, and then that's where you can pick the new algorithm that we just created. So that will go ahead and point to the DARKNET YOLO version 4 algorithm that we just created in SageMaker. So we've already established what instance types are available to us. So, and I'm not sure why you can see more than the ones that are allowed for your algorithm, but anyway, I just selected the one that we have available for training, which is a P2 extra large, has a K80 GPU, I believe, NVIDIA GPU. I'm going to go ahead and add 6 gigs of extra storage just because these things don't have a lot of storage. I can't remember the exact amount that they come with, but I ran into storage issues on the first training run, and so I just bumped it up to 6 and it was fine. Okay, so I'm not good at doing the mental math on the fly for the stopping condition, so I want this thing to run. Basically, I'm just going to give it 6 hours to run, so I don't like looking at it in seconds. I'll just change this here. And then I don't care about VPC. I don't have to talk to anything else within my VPC. And then you get the hyperparameters. So these are the ones that are optional are just blank, but then the ones that are required are filled in up here. So these are the default values. You can go ahead and fill them in depending on what you want to do for your training. If we come down here, we've got our 2 channels that we've already established within our algorithm. And so I'm just going to call this one training, file type input. The content type I'm using is JPEGs, not doing any compression. It's coming from S3. And here is the bucket info for where that data is located. So remember, we already looked at that location in S3. So the training and the testing are very similar. Obviously, the only difference is the data that's in those particular directories. Now the checkpoints, this is an optional configuration. So this is where, in my case, I'm going to be spitting all of the weights files every so many epochs during training. So this is really where I want to make sure that I've got this set up, because it will output the kind of the final results to this output location. But typically when I'm training, I like to monitor the progress, and then if it's already, if the error is low enough early on, then I can typically stop training and then just save some money, save some time. And so I define these checkpoints directories, and then I'm able to get them sort of as they're produced. And then finally, the output location, like I said, that's kind of where everything gets tarred up. And so you specify that. And this is where I believe if you wanted to create like an endpoint using SageMaker, it's going to go to this model output directory. So it's going to try to pull the actual output tar file and then utilize that for the endpoint that you create. You can optionally manage spot training, which I'm not going to. And then you could go to create training run, which again, I've already done. So I'm just going to quickly pull up the previous training run here that I've got. And if we come in here, you can see this one is completed after so many seconds. Again, I'm assuming I don't want to guess. I think it's 6 hours, but anyway, or less than 6 hours, I should say. So if we come down, we can kind of see kind of basically how everything went. We've got our output path here, which we can open that up. We see that we've got our checkpoints that have been written to S3. Again, we see the metrics that we're looking for within the logs. We've got our actual output, which is where the tar file is going to be spit out. Our hyperparameters for this training run, these are the values that were set. And then I mentioned that you can use the metrics and actually see them in the graphs down here. And so this is where we can see our loss through the training. So I mentioned that I want to get the checkpoints kind of as they're being produced in that checkpoints directory. And that's because if you come over here and look, you can see that loss pretty much leveled out. It did continue to drop a little bit, but within the first hour or 2 hours of training, the loss was about as good as it's going to get, or probably good enough for my use case. So I could have stopped training early if I wanted to, just kind of monitoring this graph. All right, so sorry to end it abruptly there.
Are you done, Alex?
I am, yep. Sorry for going over, but yeah, that's it. So if there's any questions or.
Yeah, I have some questions.
Yeah, absolutely.
So thank you for sharing that amazing talk. Let's say that some of the attendees have, let's say, never heard about SageMaker or getting started with machine learning and using SageMaker to work on machine learning. Can you recommend what would be a good way for them to start learning about this stuff?
Yeah, absolutely. So the training content that Amazon provides, they've actually got a lot of the content that they use internally, they've now made public. And so I believe, I'd have to get back to you on this, but I think it's under the AWS training. And they've got a whole section just on machine learning. And they've got YouTube videos, and they've got everything kind of broken up into modules so that you can go through and walk through specific tasks and scenarios that you would want to actually learn. So.
Great. So there's another question. So when would it be best to, so there are built-in algorithms, right? And then there are options to basically to use a container. What would be the suggested, let's say, framework or way of dealing with like available solutions before choosing the algorithm or basically the resource to use for training, etc.?
So if I understand the question right, really the algorithm is going to depend on the problem you're trying to solve. So, it depends on if it's like a supervised learning problem or a computer vision problem or a unsupervised learning problem. And so there's algorithms for all of the different types of machine learning problems. If you go to that page that I shared with the built-in algorithms and you click on any one of them, they actually kind of do a good job explaining what the algorithms are designed for, what the types of problems that they are intended to solve. And then not only that, but they'll go through all of the parameters that you need and all the data that you need and how to organize it within S3 and how to set up the whole training run in AWS. So that built-in algorithms page is a great resource for learning, where to start, what algorithms to use.
Great. All right. So thank you again, Alex. For the other questions, we can discuss those offline. So for everyone, let's give Alex a big round of applause.